What's up, you guys? This is the last one that I'll be wearing the same thing. Okay, please forgive me. This is the only time that I have to make an intro, and I'll be busy recording the rest, whatever day it's possible for me. And guess what? That's how you start a video, right? With yapping. So it will be okay if you watch this back to back to back, but if you're watching it in different days, it's kind of weird, right? But it is what it is. Uh, Still me, still the great teacher Kandara. Hopefully, still great. And this one right here, we're gonna talk about a combination of things. Now, it's a disclaimer: if you're my student, um, the one that you're probably studying for, if you're watching this, is the STAP week thing, right? That where your batchmates taught you. They probably did well. That's why you're supposed to be not watching this video, only for practice. But anyway, it's going to be the second part or the secants. But I'm gonna combine this entire video, including chords, secants, and tangents, and their relationship to a circle. Okay, so once again, this video is all about chords, secants, and tangents, the theorems involving them, and their relationships with a circle. Let's go. We're going to discuss three different theorems, and at the same time, we're also going to show different kinds of examples wherein we can combine them and at the same time involve a little bit of algebra. So in this case, let's start with our first theorem. Our first theorem is what we call as the intersecting chords angle theorem. Basically, this happens when two chords intersect. And we know that chords can be found inside a circle. Hence, when these two chords intersect, the vertex is inside the circle. If you look at the illustration on the right, the vertex is somewhere here. Again, not because it looks like it's at the center, it's automatically at the center. The rule in geometry is that we do not assume, we can state facts based on the given. Since it's not given that it's the center, don't mind it. It's just the intersection point, okay? That's the vertex. So basically, the first theorem states that if two chords intersect inside the circle, then the measure of the angle formed is equal to 1/2 of the measure of the two intercepted arcs. Now, to clarify this, the intercepted arcs that are being mentioned here are basically, first off, it's important that you take note of what is our reference angle. Hence the symbol here, the theta, the theta symbol here. So you have to take note of our reference angle. On the illustration on the right, I use the red marking for our angle that was formed by those two intersecting chords. So first, its first intercepted arc will automatically be this one right here. This is the first intercepted arc of this angle. Now, what would be the other intercepted arc? Basically, it is the one opposite to it. So it will be the one here. If you find that confusing, let us label our given circle. Say that have here point A, this is point B, this is point C, D, and E. If you take note of this, the angle can be found at angle AED. Okay? That's the red symbol. That's AED. Oh, sorry. AEB. Can't even understand my own writing. So in this case, angle AEB is equal, or the measurement of angle AEB is equal to the measurement of arc AB plus the one opposite to it, the measurement of arc DC, all over 2. So that's the application of it. Once again, first, you get your angle. We have angle AED. Therefore, its intercepted arc is none other than AB. And the one opposite to it is DC or CD. So that's where the formula came about. So that is for the intersecting chords angle theorem. So we will use this kind of concept later on to solve, but there's an important thing that we have to discuss first that is related to Theorem 1. These two theorems or concepts were discussed back in your grade 8 lessons. First up, we have the vertical angles theorem. So vertical angles, basically, those are angles that are opposite to each other and are formed by intersecting lines. And when this takes place, the vertical angles are deemed to be congruent. Next, we have a linear pair. Basically, it's a pair of angles that are adjacent to each other and they are supplementary. So looking at the right, the illustration again, we have our given intersecting chords. Let's name it again. Let's say this is F, G, H, I, and J. So if you take a good look at this, these two intersecting chords form four different angles. So basically, we can say that we have our angle here at GJH. I will take note of that on the left side also. You have angle GJH. And if you follow the concept as mentioned in vertical angles theorem, that angles that are opposite to each other will be congruent. So what is opposite to GJH? Well, that will be angle FJI. So if you're still wondering what I'm talking about, again, this is GJH. So what is opposite to it? None other than FJI. So they have equal measures. Since they have equal measures, we can put a curve here. Now, disclaimer, some students or some teachers also decide to not just do curves, but sometimes put tick marks on top of curves. It doesn't matter. What matters is that if they're congruent, they should have the same symbol. Okay, next. In this case, there's another pair of vertical angles we can identify here. I'll just use a different color so that it won't be confusing. The angle formed in FJG is the same measurement as the angle formed in IJH. So we can take note of that. Again, angle FJG is congruent to the angle formed at IJH. Okay, so that's the concept of vertical angles theorem. This takes place when there are two intersecting lines or intersecting segments. I'll just erase this one since we're done with vertical angles theorem. So how does the linear pair work? So not only do we have vertical angles when we have two intersecting lines, we can also have linear pairs. Basically, it's from the name itself, linear. So you base it off from a line. So for example, you have here the segment FH. It's a straight segment, right? So there are two angles that were formed here. One here in FJG, like earlier, and one here in GJH. These two things do not have the same measurement. We cannot say that yet, unless, again, it's perpendicular. But again, we cannot say that yet. We don't know. But what's important for us to remember is that these two angles, the measurement of FJG, and if you add that to the measurement of GJH, it should be equal to 180. Why? Because it's supplementary. Okay, so these two things here will help us also in developing our skills and applying it with in line with theorem 1. So we're going to have examples where we can solve for everything based off of theorem 1, vertical angles theorem, and linear pair. Okay, so let's apply these skills with our examples. Start with the first one. So for example, we have here the given measurements: 35 degrees for NE, 85 degrees for arc NI, 95 degrees for arc IL, and 145 degrees for arc EL. One of the most important things that will help you out a lot in problems or exercises in terms of circles is, of course, remembering again um, the concept and the measurement of entire circles. For circumference, we know that for a circle, it's automatically equal to 360 degrees. If you add 35, 85, 95, and 145, it will give you 360 degrees. Now, let's say for this example, we are looking for the following. Let's say we're looking for the measurement of the one formed here. I'll name this as this angle. Name this as, can name it as, H. Name this as H, and we want to look for the measurement of the angle IHL. Okay, so this is our reference angle. This is the one that we're referring to. So now what we need to do is to identify its first intercepted arc. So the first intercepted arc is IL. So we're gonna write here on the right first. This is our first example, the long method of doing this. So we're gonna write here the measurement of arc IL. We're gonna add that to the one opposite to this one. Basically, that will be NE. Okay, so that's the one opposite to this reference angle. And then we're gonna do is add the measurement of, right, I used the wrong pen. The measurement of NE. And then we're gonna divide that by 2. So the next step is to simply substitute. So we have the measurement of angle IHL equal to IL, which is 95. Again, since there's the letter M for measurement, you don't have to put the degrees anymore. Plus, for NE, that's 35. Then divided by 2. So the measurement of IHL is equal to 95 plus 35, that's 130. Divided by 2. This will give us 65. So this helps us in identifying our first angle here. This one is 65 degrees. And then if you understood the concept earlier, wherein we explain the concept of vertical angles theorem, and at the same time we also explain the concept of linear pair, we know that since IHL is 65 degrees and HE is also 65 degrees. Now to get the rest, all you have to do here is to subtract the measurement. So for example, you have here NHI, you would like to look for it, all you have to do is to subtract it from 180. So you'll have 180 minus 65. And the answer here will simply be 115. Why? Because they form a linear pair. So this will be 115 degrees. Same case, this will also 115 degrees. And if you observe it, we look at the measurements. 65 plus 65, that will give you 130. 115 plus 115, that will give you 230. And if you add all of those measurements, it will lead you to 360. That's an important detail that you have to remember. The ones in the middle should also be able to form 360 degrees. Okay, let's proceed with another example. Now in this example, we have here 71 degrees and 129 degrees. And again, we're looking for the measurement of this angle formed in BFC. Or it could be AFD. Either way, it's going to be the same measurement. So let's solve for it. So let's say we have the measurement for BFC. And since we have shown earlier the complete solution to save time, we're going to substitute the values already. But still, I'm going to show you what we're talking about. So for BC, the measurement is 71 degrees. So let's have 71 degrees, or 71, sorry. Next one is the one opposite to it, AD. I used the wrong pen again, AD. That's 129. So we will substitute 129, so plus 129. Guys, the formula is right here. You can see it here. So divide it by 2. If you continue with this 171 plus 129, you'll get 200 divided by 2 for the measurement of BFC. Therefore, the measurement of angle BFC is equal to 100. Okay? And again, you're just looking for BFC, but if you want to look for the rest, again, you can apply the skills we have acquired earlier. Since BFC is 100 degrees, AFD is also 100 degrees. And just like earlier, 180 minus 100, you will get here 80 degrees. Vertical angles theorem, this will also be 80 degrees. And again, if you add all these 4 measurements, you will get 360. So again, all you have to do is to be mindful of the formula and then substitute, then apply those skills. Same with linear pair and vertical angles theorem, so that you will be able to find the measurement of the rest. But again, the reason why I'm showing you how to get all of the measurements, so that when you have a complicated problem, you'll be able to do it. But all is being asked of you sometimes is just one. If you're being asked to find one, just look for one. Don't need to find all. Next theorem is theorem number 2. This is now the tangent-chord theorem. Earlier, it's chord-chord. Now we have tangent-chord. So basically what happens here is that a tangent and a chord intersects. Therefore, you will find the vertex on the circle. Earlier, the vertex was inside. This time, it's on the circle. So in this case, if a tangent and a chord intersect at a point of the circle, on the circle, then the measure of the angle is one half the measure of the intercepted arc. So if you look at the illustration on the right, you can see here that they intersect at this point. Why is it not coloring? Wait, it's here. Now, since that's the vertex, the one in violet, the one I'm highlighting again, is the angle that was formed. Now, the measurement of this angle, of this theta, is basically the half of its intercepted arc. The intercepted arc is basically this one. Okay? That arc right there. You may interpret it this way. So basically, when you have a tangent and a chord that intersects each other, the intercepted arc is basically the arc inside the tangent and the chord. Okay? We're referring to this one. We're referring to this one, not the other way around. Okay. Again, that's why I mentioned you may interpret it in such a way that the intercepted arc is the one inside or between the tangent and the chord. You may interpret it that way. Simple formula, intercepted arc divided by 2. So let's have one example right here. So we have here 76 degrees. But again, since it's the first example, let us write it completely. So our reference angle is for ABC. It could be CBA, it don't matter. So now, what is the intercepted arc of this one? Intercepted arc is basically here, because it's the one in between the tangent and the chord. The tangent that we have is AB. Our chord here is BC. Okay, it actually looks like it's actually a secant, to be honest, since it extends. But always remember, a secant contains a chord, so it still works. So to continue with this one, the intercepted arc is arc BC. So arc BC divided by 2. If you continue with this one, the measurement of... Oh, wait. That's correct. Yeah, that's correct. The intercepted arc is BC. But here's a question though. I put the harder example in the beginning, but don't worry, it's fine. You have the measurement of angle ABC equal to arc BC over 2. That's correct. Now the question is this. What is given here? What is given here, guys? The one that's given here is the measurement of ABC, which is 76 degrees. So the one that is missing here is the measurement of the arc. And it doesn't have to worry that much. All you have to do is to substitute. So since you have 76 degrees, the measurement of ABC will be 76. Do we have a measurement for arc BC in this image? No. So all you have to do is to keep it that way. And you'll be end up with something like this. So you're like, sir, what am I gonna do now if you have something like this? All you have to do is to treat it like your linear equations, wherein you manipulate the equation such a way that you will be able to find the value of the missing part, or of the said part or mentioned part. Sorry if I'm stuttering here. So you multiply 2 to both sides. The simple reason behind that is to eliminate these 2 right here. So 2 times 76, that will give you 152. And then arc BC over 2 times 2, that will simply cancel this whole thing out. So therefore, our arc BC is equal to 152. And if you want to verify that, let's use the formula. The measurement of our angle ABC is equal to 152 divided by 2. And that is indeed true. Okay, so basically here, what I would like you to understand with this example is that not because that's the formula, that's the way it's going to be used all the time. Sometimes you have to derive it, and you don't have to worry about derivation. Okay, so if you want to get the intercepted arc instead of the reference angle, all you have to do is this. Diba, you have the reference angle equal to intercepted arc. To get the measurement of the intercepted arc, all you have to do again is multiply both sides by 2. So therefore, it will give you 2 times theta, the angle theta, is equal to intercepted arc. And that's it. So the measurement of that theta times 2 is equal to the measurement of the intercepted arc. You may derive it this way, or you may simply substitute and apply the skills you've learned with linear equations. I'm gonna show it more like that, the one that I did first, because that will help you out a lot with the other solutions. Let's continue with another one. So I have here, this one's much easier because this time we're given with the actual arc measure. So the actual arc measure here is from Q to R, we have 146 degrees. Do you have the angle for QRS? We don't have the measurement. That's why we're going to look for it. So let's start with QRS, the measurement of this intercepted arc. Again, it's 146. Then we divide it by 2. So the measurement of QRS is equal to 73. And that's your answer. As fast as that. Now, again, just to add up this one, because this one is pretty easy. If this one is 146, what would be the measurement of this arc right here, this major arc? So you will simply subtract it from 360. 360 minus 146, that will give you 214. I'm mentioning that as early as now so that we will be able to apply it later. Let's have another example right here. Similarly, this one is not that hard, and the angle here is way. So we're looking for the measurement of angle way, or U, your choice how to sequence that. The intercepted arc here is for arc WY, sorry, WE, we, or EU, your choice, and then we divide by 2. So you have, again, if you want to show it the complete manner, you'll write, for example, arc EW divided by 2. Then therefore, the measurement of angle way is equal to the measurement of arc EW. Substitute that, you'll get 123 divided by 2. So the measurement of angle way is equal to 61.5. Yeah, this is correct. Yeah, it's correct. Okay, let's go with the last theorem. Yay! Let's go. Exterior vertex at I, guys. So exterior vertex, sometimes this is the problem with kids. They tend to forget how to read. Exterior means outside, right? So the vertex is formed outside, or we find it outside. So the angle is formed outside. Now, to make this quick and at the same time understandable to everyone, exterior vertex, the reason why it's named like that, because it takes place in 3 different cases. So the possible cases that we have here is the one that you're seeing on your screen in the illustration. This is basically what we call as tangent-tangent. Why? Because you have 2 tangent lines or rays or segments that forms an angle outside. We can also have secant-secant. You can have 2 secant lines or rays that form an angle outside. That can still work. And the third one, we can have tangent-secant. And you're like, sir, why you're just mentioning this now, or not showing different kinds of images or examples? Because it don't matter. It don't matter. What matters here is this exterior vertex. As long as you remember that these 3 theorems have differences in terms of where the vertex is located, you will not have a problem. The first one, the vertex can be found inside the circle, wherein it's the intersection of the chords. In Theorem 2, we can find the vertex on the circle, and then for the last one, we find it outside. That's why exterior. So basically, as stated here, if a tangent and a secant, 2 secants, or 2 tangents intersect in a point outside the circle, then the measure of the angle is equal to 1/2 of the difference of the intercepted arcs. So if you can see the illustration on the right, I have differentiated colors already. So basically, the 2 arcs we're talking about is the red arc and the purple arc here. So basically, there are 2 arcs that will be subtracted. Now, there's a specific reason as to why the larger arc must come first. Remember, we're talking about measurements. There is no such thing as negative degrees in terms of the measurement of an arc. Okay? I know there is negative degrees in temperature, but not in circles. Remember that. There's no negative value. That's why the larger arc must come first before the smaller arc. Okay? So if you're having a hard time identifying it, the larger arc will be this one. And then the smaller arc will be this one right here. So you simply subtract their values. Okay, let's have an example. So we have here 125 degrees. We have EY. I mentioned EY instead of writing it there on the image because it will be confusing. Okay, so we'll have our reference angle. I'll write it first here. We're going to look for the measurement of QWT. Why is it QWT? Because it's QWT. This is our reference angle. Okay, so to find its measure, larger arc. The larger arc again is QT. It's 125. So I'll put QT again because it's our first example. The measurement of QT minus the measurement of the smaller arc EYA. So we will have that minus EY all over 2. So if you continue with this one, measurement of, wait, I haven't adjusted the, sorry, measurement of angle QWT is equal to, QT is 125, and then minus EY, which is 27, then we divide it by 2. Continuing with this one, QWT is equal to 98 divided by 2. Therefore, the measurement of angle QWT is equal to 49. As fast as that. That's it. That's the measurement of our angle. Let's go to our next one. Now here, the difference between this example and the previous one is we have to somewhat derive it a little or manipulate the equation in the middle. So first, we have to substitute. Our reference angle here is angle, the measurement of angle ABC. Larger arc is arc AC minus the smaller arc, which is arc DE. So we're looking for arc DE here. Then divide by 2. The measurement of angle ABC, as you can notice here, it's already given. It's 23 degrees or 23. The measurement of arc AC is 120. DE, it's not there. So measurement of arc DE is not yet mentioned, over 2. So all you have to do again, first multiply both sides by 2 so that we can eliminate the denominator here. So we're gonna have 2 times 23, that gives us 46, equal to, again, just simply cancel this out, and then you will have 120 minus measurement of arc DE. What we have to do here is to isolate the variable, or in this case, isosceles, isolate the part. So we will transpose 120 to the other side. So we're gonna have 46 minus 120 equal to negative measurement of arc DE. Sir, sabi niyo walang negative measurement. Chill out. Chill out, okay? Trust the process. Okay? 46 minus 120, what are we gonna have here? 74. Negative 74 equal to negative measurement of arc DE. So what do you do here? All you have to do is divide both sides by negative 1 so that you can cancel out the negative sign. So cancel this out, cancel this out. Therefore, this will lead us with that answer. 74 is indeed the measurement of arc DE. If you want to verify that, we can apply the formula and see how it will go. Let's see if this is correct. Let's pretend that ABC is the one that's missing. So we're going to have the measurement of angle ABC is equal to AC being 120 minus 74 divided by 2. If we continue this one, 120 minus 74, we're going to get 46 divided by 2, and the answer is indeed 23. So it works. It's correct. So that's how it works, right? Basic stuff. Let's go. Other one. Now here is actually something that I really want to show. As you can notice here, we're looking for the measurement of our reference angle, ZIN, but we don't have the measurement for ZN also. But as you can notice here, just to clarify with the example, we have ZON that is equal to 265 degrees. So how will you find the missing one? Again, based on the image, we have the measurement of arc ZON equal to 265. So how do you find ZN, the smaller arc? It's not complicated. Always remember, circle 360. So 360, sorry, minus 265, the answer is 95. So that means that this arc right here, ZN, is equal to Zn is equal to 95. And therefore, you have your arcs, the larger and the smaller. So you can continue. So let's find the measurement of angle ZIN. Larger arc is 265 minus 95 divided by 2. The measurement of angle ZIN will be equal to, what will this be? 170 divided by 2. The measurement of angle ZIN is therefore equal to, wait, I have to be careful here. I'm a bit dizzy now. It's 85, I think. Yeah. Is it 85? Yeah, it's 85. If my calculations are going wrong, please double check it. I am so tired. And I'm dizzy. Wait, anyway. Why am I yapping? 265, 95. Yeah, it's about right. 170. Okay, that's it. Let's have last two examples, and these examples will again include a variety of solutions. It will be a combination of the theorems. Okay, let's have our first one. As mentioned earlier, we'll have a combination of the theorems. You have here, not only do you have intersecting chords, but also an angle formed outside. So I'll highlight it for you guys. Look at this one. Chord EB and chord AD intersects. Therefore, we will apply the following. So we have theorem 1 first. Theorem 1 again, guys, is intersecting chords or chord-chord. And since we have intersecting chords, the formula is simple. The formula is measurement of angle theta or theta will be equal to intercepted arc 1 plus intercepted arc 2 divided by 2. In this case, if we're looking for ACE is our angle here, right? So if we're looking for this one, our intercepted arcs are AE and BD. Okay, so we can notice it there that there are values already. So let's solve. So the measurement of angle ACE is equal to 130 plus 70 divided by 2. So this will become 200 over 2 or 100. So this one is 100. So this makes this 80. This is 80. This is 100. But you're not looking for it anyway. Next is AFE. We're looking for the measurement of AFE. And as you can notice, the angle is formed outside. That is theorem number 3. Theorem number 3 simply states that you have different kinds of cases, right? Tangent-tangent, secant-secant, tangent-secant. But what matters is that when the vertex is outside. The formula is the measurement of the reference angle, or whatever it is we're looking for, is larger arc minus smaller arc all over 2. So we don't have the measurement for AFE. So that's what we're looking for. So measurement of angle AFE is equal to what arcs the what's the larger arc here? 130. Smaller arc is 70. So our solution will be 130 minus 70 divided by 2. 130 minus 70 is 60 divided by 2. The answer there is 30. So ACE is equal to 100. AFE is equal to 30. So those are our answers for this example. Last one, we're gonna have some algebra. Bro, it's a bra moment, right? We're gonna have some algebra for this one. But you don't have to worry. We have here Wendy. Oh, sorry. Well, yeah, it's Wendy. But given we have arc ED, 3x plus 4 degrees. I'll write it again so that you can see it in a bigger manner. So let's say that the measurement of arc ED is 3x plus 4. Sorry, 3x plus 4. Manipulation degrees dapat. 3x plus 4. And the measurement of WY is equal to 5x plus 10. And lastly, you have the measurement of angle end is equal to 30. So if you look at our figure here, we have WY, which is this. We have ED, and then we have the angle formed here at N. Okay, so basically what we need to do is to find the measurements of arc ED and arc WY. But before that, we have to find the value of X. You don't have to worry. All you have to do is to remember our formula here. So this is for Theorem 3. Theorem 3 states that the measurement of the reference angle is equal to larger. I'll just write larger, sorry, but because there's no space, minus the smaller divided by 2. So what you have to do here, since you have the given already, all you have to do is to substitute. So let's say we have the measurement of our angle END is equal to the measurement of our larger, which is WY. So measurement of arc WY minus the measurement of arc ED divided by 2. So what you're going to do next is, of course, substitution. END is 30 equal to the measurement of WY, that's 5x plus 10. And then you have minus, please put it in a parenthesis when dealing with binomials, okay? So put in here 3x plus 4 and then divided by 2. So that we will save space, well, let's multiply this first by 2. Okay, why are we multiplying by 2? So that we can eliminate this one. Okay, to eliminate this one, so 2 times 30, that will give us 60. So 60 is equal to, so let's now bring down 5x plus 10. Now I'll slow down here, please take a good listen. It's minus the parenthesis of 3x plus 4. Therefore, you have to distribute this negative symbol to the binomial factor. Oh, sorry, binomial. What did I say, factor? Oh god, I missed factoring from grade 8, but you don't have to say that. Binomial only. So distribute it. So instead of 3x, it will be minus 3x. Instead of positive 4, it will be minus 4. Okay? After that, let's simplify. So I'll have 60 is equal to 5x minus 3x. That will give us 2x. 10 minus 4, that will give us positive 6. And isolate the variable. Let us transpose 6 to the other side. We'll have 60 minus 6 is equal to 2x. Therefore, we'll have 54 is equal to 2x. And if you continue here, 54 is equal to 2x. Divide both by 2. Our x is equal to 27. So we have our first answer. So now that you have x is equal to 27, all you have to do is to substitute this value. Okay? To save space, I'll erase the formula here. So again, our x is equal to 27. And now all we have to do is to substitute. So from 3x plus 4, this means it will be 3 times 27 plus 4. So 3 times 27 is 81 plus 4, that will give you 85. Next, here 5 times 27 plus 10. So we're going to have 145. That's it. So if you want to verify this using the formula, you're going to have 145 minus, basically for verification on to guys, if you want to lang, you're going to have 145 for WY minus 85 ni ED divided by 2. 145 minus 85, that will give you 60, divided by 2, that will give us 30. So that's it. So for those who are still wondering or found the explanation a bit fast, you don't have to worry when dealing with algebraic given. When they're algebraic, you don't have to worry. All you have to remember is the formulas you substitute, okay? The techniques here, since the formulas are pretty basic, all you have to do is remember to make sure that there is no fraction. To do that, all you have to do is multiply both sides by 2. That's what we did here. Then after that, make sure, since we're dealing with subtraction here, guys, you distribute the negative sign to the binomial or to whatever is um, the one that is the smaller arc, okay? Then after that, we combine like terms, isolate the variable, find the value of x, then we substitute to get the final values. So that's how it works. And that's about it. Yo, the color is different now. Yeah, yeah. We're vibing here. Yeah. My hair is herring. Um, this is real, by the way. I didn't perm this thing. It's natural. Coco, wanna say hi? Wanna say hi, Coco? Nah, she doesn't want to. But anyway, I hope you guys learned a lot about chords, secants, and tangents. I keep looking at the book. I'm like, wait, what's the title? It's chords, secants, and tangents. For CSA students, you have your Math Plus. This is everything that we're discussing. I'm just putting it into words. And if you guys don't have it, especially if you're not my student, if you're using different books, it's gonna have different examples. I think that's much better, right? So I'm using our book in CSA as our basis, and you can use whatever book you have. So I think it's a plus plus for everybody, right? If this makes sense. I don't know. Peace out, everyone. Wait, what's the outro? What's the outro again? Good morning, good afternoon, good evening, and good night. That's from Two Man Show, by the way. Now that I mentioned that, people are like, "Sir, why are you commenting on that?" Who knows? This is a show, right? Peace out. Respect, everybody. I'm so sleepy. I'll probably have to go get out and get some coffee. Wait, why am I yapping? Yeah, the yapper's out.